We use our computers every single day, but have you ever just stopped and wondered what's actually going on in there? And I don't mean the software or the apps, I mean the physical journey your commands take. So today, we're going to follow one single command to understand how a computer really thinks.
Just think about it for a second. You press a single key, let's say the letter G, and boom, it's right there on your screen. You think it's magic, right? But it's not. It's this perfectly coordinated dance of electronic parts, all happening at speeds that are just impossible to imagine. So, what is that dance? What happens in that tiny sliver of a second? Well, that is the exact journey we're about to follow.
Okay, so before we can follow that command, we've got to meet the players, right? We have to get to know the physical world our little command travels through, the body of the machine itself, its hardware. Okay, so every computer kind of has two sides to its personality. First, you've got the hardware. That's all the physical stuff you can actually touch. The keyboard, the screen, all the little chips inside. And then you have the software. Those are the invisible instructions that tell all that hardware what to do. For our journey today, we are focusing completely on the hardware, the body that actually carries out the commands. All right, so let's get back to our key press. The journey officially kicks off the second you give the computer that command. So how do we even talk to the machine in the first place? Well, we use its senses, the input devices. Think of them as the computer's senses. They're the super important hardware that translates what we do in the real world, a click, a word, our key press, into a digital signal the computer can actually get.
I mean, we use these things all the time without even thinking about it, right? Your mouse translates your hand movement, your microphone grabs your voice, your webcam sees what's in front of it. But for our story, the real hero is the keyboard. The second you press that key, our command is officially in the system, and its journey has truly begun.
Okay, our command is in. What's next? Where does it go? Well, it gets sent on this super fast trip straight to the command center of the entire operation, the digital brain. And here it is, the central processing unit, or as we all call it, the CPU. I mean, if all the hardware is the body, the CPU is, without a doubt, the brain. This is the part that follows instructions, makes all the decisions, and just crunches all the numbers. Our simple key press has just arrived at the CPU, ready to be understood. Now, this brain is really more like a tiny, super efficient office. First step, you've got the control unit. That's the manager, the traffic cop, telling all the data where to go. Next, you have the arithmetic and logic unit, or ALU. That's your math whiz, the part that handles all the calculations. And finally, you've got registers. Think of these like little sticky notes, holding the exact piece of data the CPU needs at that very instant. Our key press is being sorted out right here in this tiny office.
Right. But what good is a brain without memory? To do anything with our command, the CPU needs a place to work, a place to access information. It needs memory. And you know what? Just like us, a computer has both a short-term and a long-term memory. And the best way to think about this is with an analogy. Primary storage, which is RAM, that's like your workbench. It holds everything you're actively working on right now. It's incredibly fast, but, and this is key, when you turn the power off, the workbench gets wiped completely clean. Secondary storage, like a hard drive or an SSD, that's your filing cabinet. It's where you put stuff for the long haul. It's a little slower to pull things out, but your files are safe and sound even with no power. And that filing cabinet comes in all shapes and sizes you totally know. You've got the classic spinning hard disk drive, the way faster solid-state drives we have now, portable USB drives for taking things with you, and even cloud storage, which, let's be honest, is just using someone else's massive internet-connected filing cabinet.
Okay, we are almost there. Our command went in through the keyboard, got crunched by the CPU with a little help from RAM, but there's one massive step left. How do we even know any of this happened? We need to see the result. And this is where output devices come in. Their whole purpose in life is to take what the CPU did and turn it back into something we humans can actually understand, whether it's something we see, hear, or even hold. Of course, the most obvious one is your monitor. That's the final stop for our little letter G. It finally pops up on the screen. But hey, a printer's spitting out a document, or your speaker is playing music. Those are also perfect examples of the computer showing you what it's done. So we've met all the individual parts. But here's the thing. The real magic isn't in any one piece. It's how they all talk to each other and work together as this one lightning-fast connected system. This table really pulls it all together, doesn't it? Just think of it like a sports team. Input gets the game started.
Processing does all the heavy lifting and strategizing. Storage remembers the playbook. And output shows you the final score on the scoreboard. Our one key press made this entire team work in perfect harmony, all in a fraction of a second. But what connects this whole team? How do they even communicate? Well, that's the motherboard's job. It is the central nervous system, the superhighway of circuits that physically links every single part together, letting the brain, the memory, and all the senses talk to each other instantly.
And here is why any of this matters to you. The quality and the speed of every single member of this hardware team, that is what determines how fast your computer feels. A faster processor, more RAM, a quicker hard drive, each one of those things makes that journey from your finger to the screen happen just a little bit faster. When we talk about performance, we are talking about hardware. And that's really the bottom line here. It doesn't matter what you're doing, something simple like typing a letter or something crazy complex like editing a 4K video. Every single thing you do relies on this incredible high-speed teamwork happening inside that box. So the next time you tap a key, you'll know it's not some kind of magic. You'll know about the incredible journey that little command is taking, and the entire team of components working just for you. So the only real question is, now that you know the team,